Hello everybody, welcome to ICTS Learning Module 5 Data Science Applications. In today's session, we'll be learning about natural language processing and its implementation in Python. What is NLP? Natural language processing is NLP is about developing applications and services that are able to understand human languages like speech recognition, speech translation, understanding complete sentences, understanding synonyms of matching words, and writing complete grammatically correct sentences and paragraphs. Some successful implementation of NLP includes search engines like Google search engine, Yahoo, etc. Google search engine understands that you are a techie guy, so it shows you results related to that. Social website feeds, for example Facebook newsfeed understand your interest using NLP and shows ads and posts related to those interests. Speech engines like Apple Siri, Google Assistant. Spam filters, for example email spam filter. These spam filters understand what's inside the email content and see if it is spam or not. There are many open source NLP libraries. Some of them are NLTK, that is Natural Language Toolkit, Apache Open NLP, Stanford NLP Suite, Gate NLP Library. For our session, we'll be using NLTK since it is the most popular library for NLP and is written in Python. It has a big community behind also. NLTK is also very easy to learn. Now let's install NLTK. Let's see how to install in Python. Run cmd as administrator. Click yes. Type pip install NLTK. You can see NLTK is getting installed. Allows some time for the installation. You can see it has been successfully installing the package NLTK. Now it has been installed. Type Jupyter Notebook to run Jupyter Notebook. Then click on new Python 3. Then type import NLTK download. Then click run. Wait for a moment. This is showing information that NLTK downloader. Select all and download. Click download. Now we can see that it has been downloaded. It will take 15-20 minutes in your system also. So you can put into download and then after return back. Next, let's look into some basic functionalities of NLTK, and then later we'll look into some applications. So type from NLTK, tokenize, import, send, tokenize, word tokenize. By this, a sentence or a data can be split into words using this method called the word tokenize. Next, type data is equal to, this is a complete sentence. Next, print in bracket word tokenize data, click run. This will show the following output as this comma is a complete sentence. So following output of separated words we can see. Similarly, sentence can also be tokenized. Simply change to sent tokenize. Let's change the data. Type data is equal to, this is a complete sentence, this is another sentence. Print sent underscore tokenize data, click run. This will give two sentences separated. We can see it, this is a complete sentence, this is also separated by another sentence, so this is another sentence. Next is stop words. Text may contain stop words like the, is, are. Stop words can be filtered from text to be processed. There is no universal list of stop words in NLP. However, the NLTK module contains a list of stop words. Type from NLTK corpus, import stop words. Stop words equal to set stop words words English. This will give us the list of all stop words in NLTK library. Next, type words equal to word tokenized data, words filtered equal to, in bracket, for W in words, if word in not in stop word, then words filtered append, in bracket W, print words filtered, click run. This will give us the filtered data with the stop words removed. Next, we learn about stemming. A word stem is part of a word. For example, the stem of word waiting is wait. Given the word, NLTK can find the stem. Let's start by defining some words. Words equal to game, gaming, gamed, games. Next, import the modules from NLTK stem. Import Potter stemmer. Type PS equal to Potter stemmer. For word in words, print ps.stem word. Click run. This will give us the stems of words provided, that is game for each case. Word stemming can be done for sentences too. Consider sentence equal to gaming, the gamers play games. Words equal to word tokenized sentence. For word in words, print word, then ps stem in bracket word. Now let's run and see what it comes. This gives gaming, game, the gamers is again gamer, play is play games is game. So thus we find the stem of each word of the sentence. Next comes the speech tagging. Given a sentence or paragraph, NLTK can label words such as verbs, nouns and so on. Let's show this with an example. Document equal to the king wanted the noble knight to slay the dragon. Print NLTK pause tag, NLTK word tokenized document. Click run once you have finished. Let's see what it comes. This will output a tuple for each word, giving its speech type. The meaning of this speech code can be seen in a tabular form. For example, it can be seen from the table that NNP represents proper singular noun, JJ represents adjective, and etc. So let's go back. Here we can also filter this data based on type of word. Type, speech tag equal to NLTK pause tag, NLTK word tokenized document. For word in speech tag, if NNP in word, if NN in word is 1, then print word. Let's click run and we can see all words are proper singular nouns in the sentence and has been given NN and tagged. Next we will learn to look over the basic functions, and now we can use NLP to make simple predictions. Now let's take a problem. Given a name, the classifier will predict if it's a male or female. To create our analysis, we have several steps. First is data preparation. We use the names set that is included with NLTK from NLTK corpus. Import name. The names equal to name, female. For name in names words, male text plus name female for name in names words, female text, print names, click run. This dataset is simply a collection of tuples containing name and whether it is male or female, as it can be seen. Next step will be the feature extraction. Based on our dataset, we prepared our features. The feature we will use is the last letter of a name. Hence type, def, gender, features in bracket word, return last letter word, define feature set using feature sets, gender features N G for NG in names. Next we run. We'll find the feature sets as given. After this we have to go for training and prediction. Type, import NLTK classify, util, that is utility, import from NLTK classify, import knife based classifier. Here data modeling knife base has been used for classification. Since our dataset contains around 8,000 names, split the dataset into train and test as 80% and 20%. Train set, test set, feature sets is 6600, feature sets in bracket. So starting and ending we have put 6600, then type classifier equal to NLTK knife based classifier, train set. Then let's run and see what we find. So there is no error, means it's on the right track. Now let's go for the prediction. Print classifier, classify Gender features, take any name. Let's take Frank. Frank can be replaced by any name that you want to predict. Now click run. Gender of the name we find as output as male. This will be printed. Now try changing the names and check how good are the predictions. To check accuracy, type print NLTK classify accuracy in bracket classifier test set, click run. Let's see what is its accuracy. We can see its accuracy is 83%. Next, let's learn a problem solving of sentiment analysis, which is most popular nowadays to get the business insight. A big part of natural language processing is sentiment analysis. Consider a case study of a movie review, or you can consider tweets, so that it can be classified automatically in categories. These categories can be user defined, that means positive or negative, or whichever classes you want to. Now let's look into an example. We'll use NLTK's movie review corpus to predict whether movie review is positive or negative. The movie reviews corpus already has the reviews categorized as positive and negative. First, let's store a list containing tuples of all movie review words and their category. So let's come and type from NLTK corpus import movie reviews documents for category in movie reviews categories for file ID in movie reviews fields, then category, then documents append movie reviews words, put the file IDs, category, print documents, then once you are finished, you can click on run. Let's see how it comes. This will give the words of the first review with its classification. Next, shuffle the document list. Type from random import shuffle documents. Let's click run. So to classify the text into category, we need to define some criteria. On the basis of those criteria, our classifier will learn that a particular kind of text falls in a particular category. In this example, we'll use the top n words features. First feature, all the words will be to fetch all the words from the movie review corpus. Type all words, word for word in movie, reviews words, print all words, click run to print first 10 words. You can see it has been printed the first 10 words as computed. Next, create frequency distribution of all words. Type from NLTK import freq dist all words frequency equal to freq dist in bracket all words print all words frequency most common, click run. Let's see, we'll give the 10 most common words used. From above we can see that the most common words are either punctuation marks or stop words. We can see the values for these punctuations or the article or the punctuation is very high. Hence we will remove the stop words and punctuations because these do not carry any significance in text analysis. Remember, we had earlier described how NLTK contains a list of stop words and stored it in a variable called stop words. Therefore, print stop words and click run. These are the list of stop words stored in NLTK. Type import string, print string punctuation, click run. This is the list of punctuations. You find it very interesting because it's very simple. Let's remove the stop words and punctuations from our all word data. Type all words clean for word in all words. If word not in stop words and word not in string punctuation, then all words clean, append word, print all words clean 10, then let's click run. It can be seen that the punctuation and stop words have been removed. Now let's see the frequency distribution of clean words list. All words frequency equal to frequency distribution freq dist in bracket all words clean, print all words frequency most common in bracket 10, then click run. It can be seen that the most common words are now not stop words and punctuations, rather words that can be used for the analysis are visible. So we can see the film 1, these are the words has come as the most common. Hence, let's create a word feature using 2000 most occurring words. In the next step, type most common words equal to all words frequency most common, that is 2000, then print most common words in bracket, let's put 1900. Click run. The last 10 most common words can be seen. Let's extract just the words without their frequency. Word features item in bracket 0 for item in most common words, print word features 10, then click run. Most common words without frequency can be seen. Now let's write a function that will be used to create a feature set. The feature set will be used to train the classifier. Type def document features in bracket document, then document words equal to set document, set function removes duplicate tokens in a given list, then features for word in word features, type features contains percent word equal to word in document words. Return features click run. Remember earlier we have created document list which contains data of all the movie reviews with words as first item and category as second. So we will now loop through document list and create a feature set list using the document features functions defined above. Type feature set document features doc category for doc category in documents. Print feature set in bracket 0, then let's click run. Feature set of first review can be seen. The feature set is whether or not the most common 2000 words in the movie reviews are present or not, and the category of review positive or negative. We come at the end that it is positive. POS is given. This feature set will be used for training subsequently. Now let's create our training and test data set. Since we have about 2000 reviews, split the data set into train and test according to 80% and 20%. Type test set equal to feature set 400, train set equal to feature set 400 colon. Now to train type classifier equal to naive base classifier train in bracket train set, then click on to run. we find that training is complete. Now let's check the accuracy on the training set. Print, classify accuracy, in bracket, classifier test set, then click run. You may get error. So rectify error if you get this kind of errors. Now print NLTK dot classified. So if you miss NLTK, you will find error. Since we have typed it, we can find the accuracy is 80%, that is 0.8 is 80% is achieved. You can see the output with custom reviews as well. Let's write a custom review. For example, custom type review equal to, in bracket, let's write, I hated the film. It was a disaster. Poor direction, bad acting. First, tokenize the review to get a list of words. So type custom review tokens equal to word tokenize, in bracket custom review. Next, extract features from the review using the document feature functions. Custom review set equal to document features, custom review tokens, print classifier, classify custom review set. Let's click on to run. We can find output is negative, hence it is correct. If desired, the output can also be given in probabilities. So type prob result equal to classifier prob classify custom review set, print prob result, print prob result max, print prob result pro, neg, print prob result prob pause. Now let's click run. We find the probability of review is being positive and negative we can find from here. Here we find the result as negative and it is 99% chances that it will be negative. Probability is 99% and positive probability is very less, e to the power raised to minus 0 10 to the power 6. So positive probability is very less as compared to the negative one. Therefore, we have come to the end to our session. We have used knife based data mining rules and probabilistic approach in the sentiment prediction. Thank you. Hope you have enjoyed learning basics of NLP, NLTK and its implementation. If you have any queries, feel free to contact us at our following email address.